Next problem is pretty much the same. This table shows the approximate run times for a 16 millimeter film. Yes, film used to be literal film and it used to have a width. Now everything's digital. But given the diameter of, oops, sorry, let me brighten up the room a second. There we go. Okay, so given the diameter of the film on the reel. So if we have for example, a diameter of 5 inches, that means the total film length, if you were to roll the entire thing, would be 200 feet long. And it would have a run time of 5.55 minutes. It's crazy that 200 feet worth of tape would only last 5.5 minutes. But this is the model, or this is the data that we're going to use to come up with a model. Now it asks us to use the model to estimate the reel length, so how long the reel is, for an 8-inch diameter film. So on our calculators, we're going to do the same thing we did last time. Turn it on, go to Stat, and then we're going to go to Edit. Now, if your lists, which mine do, have anything or have some things in them, what I want you to do is go up to the column title. So I'm going to go up to L2, hit Clear, hit Enter. Don't hit Delete, hit Clear. If you hit Delete, well, there's a different thing out there. Oh, I guess I can show you. Let me show you what happens if you hit Delete. The whole column disappears. L1's gone. So if you press Stat, and you want to fix that, go back down to option 5, and it says Set Up Editor. You'll hit it, and you'll hit Enter again. And now if you go back to Stat, go to Edit, that L1's back, but it's still got the stuff in it. So I'm going to go up to the column title, hit Clear, hit Enter. Now, for this problem, we're asked to figure out the model. We're asked to use the model to estimate the reel length for an 8-inch diameter film. That means we're really only concerned about these first two columns. So we're going to type these columns in. We got 5, 7, 9.25, 10.5, 12.25, and 13.75. So we entered in all those diameters, and now let's enter in the reel lengths. The reel lengths we got are 200, 400, 600, 800, 1200, and 1600, or 1600. Always make sure that you have the same number of values in each column, otherwise it'll give you an error. So we're going to come up with a function the same way we did the last one. We're going to go to Stat, we're going to go to Calc, we're going to choose option number 5 for quadratic regression. Again, if you're using it 84, just double check, make sure it says L1 and L2. Mine do. I'm going to go down to Calculate, hit Enter, and then it gives us this whole thing. Now that data is a little bit of a mess, so we're going to have to do some rounding. I'm going to round it to just 2 decimal places. What's in your notes actually I think uses all of the decimal places. That's not super important. For what we're going to do, let's just round it to 2 decimal places. So we have y equals 14.30x squared minus 112.41 if we're rounding x plus 0.11. So if we were to graph these, now we're going to have to change our scale a little bit because our y values go all the way up to 1600. So if we go to our window, we'll go from 0 to, well, our highest x value right now is 13.75. Let's just go up to 20. For our y values, those are our real lengths. Right now our smallest is 200, our highest is 1600. Let's just go up to 2000. And we're going to graph this, and there's that. There are our points. That curve right there is what I already had in y equals. That's the old parabola we were using in the previous problem. So to get rid of that, I'm going to go back to y equals, and I'm going to clear out that previous problem. And now I'm going to actually type in the one we currently have. So we have 14.30 x squared minus 112.41 x plus 430.11. Now, if we graph that, it should match up with our points, or at least pretty darn close. You'll notice it's not quite as good. There's a couple points here, like that one and that one, that it doesn't seem to be going straight through the center, and that's okay. Going back to what we were talking about earlier, r squared tells us how close or how good of a model this is. 0.996 is pretty good. It's not quite as good as the last one. The last one was like 0.9998, which is even closer to 1. This one's still pretty good. So to get our estimate, now again, the pictures that we have in the notes are a little more accurate. They used all of the decimal places for A, B, and C. So when we look at our table is going to look a little different than theirs, but it's pretty close. So you'll see at x equals 8, for us, we get 446.03. For theirs, they got 446.38. That's just because they use more decimal places. for the most part, we're going to be pretty forgiving in terms of our decimal places. So we're going to say an 8-inch diameter film would have a real length, R-E-E-L for real, length, oops, misspelled that, of about, and since we're rounding, I'm just going to say 446 feet. So the real length would be 446 feet long.